Privacy and data confidentiality are closely related, but they are not the same. So this is very important. Okay, anybody still very confused by my example? I will want to spend a little bit more effort, because coming from Asian countries, when I say the word privacy, people don't understand what I'm talking about. What privacy? Okay, so anybody quite clear on my example? Do I need to give one more example?
I think you should take about Malaysia.
NSA. Well, when George Bush takes over, the meaning of privacy is lost. Okay, I think the only place that I know where privacy is still highly valued is still the EU. Okay, EU really values privacy. Okay, so privacy really here, it means that any form of unnecessary kind of information should not be transmitted. So things like if there is a way, okay, I give an example. In SSH, those people who are familiar with SSH, okay, you will know that if you transmit username and the public key, the communication established shows absolutely nothing about what username is transmitted across the network. Okay, that is what we mean by privacy. Okay, in the communication link, okay, there is no such thing that happens. Another way example is that I can't think of, okay, if you do, let's say for example, if you do logging, okay, other than logging where the IP address comes from, you don't lock down what the person does and stuff like that, okay? Because if you do lock down what the person does, for audit purpose, yes, you can do that. But if the information is compromised, okay, a lot of things can be gleaned out of it. So that is what I mean by privacy. So privacy and non-repudiation, okay, sorry. Privacy and non-repudiation, okay, sometimes have a form of conflict, okay? So it's really finding what we call a balance, okay, in putting the controls in place. Now, each of these security dimensions are then applied to each security perspective. Again, all the little points. You know, the one thing I hate about explaining X.AL5 is that you must explain all the key terminologies first before you can put them all together. If you put them all together and explain, it's very hard. So please bear with me for a while. Okay. Now, this diagram shows you how the 8 security dimensions mitigate the 5 threats. Okay, I give you about 10 seconds to just look through, okay, and you can see interestingly, okay, that most of these controls can mitigate things like theft or removal. And non-repudiation, okay, as you can see here, non-repudiation is the only control that can protect against all these things, all the threats. Okay, so thus proving one thing, okay, lock is something very important, okay. Digital signature and confirmation, stuff like that, are very important because it can prevent a lot of problems like this. Okay, so things like privacy only prevents only just one area, disclosure of information, and what else? What other interesting things? Yeah, so that's about it. Okay, and you can see for interruption of services related to availability. Okay, so quite a very straightforward diagram. I'm not going to go down too much into it. Now, if you want to put this X.AL5 into the picture, how can I use X.AL5, okay, in really to secure my network? Understanding the concept means that first, when you first define and plan a network infrastructure, okay, and the necessary policies and procedures, or even deploying the right technology at the planning stage, you can use this standard. You can use this standard during the implementation stage. Okay, and you can use this standard even during the post-implementation stage. Okay, so this standard is very flexible. Okay, I'll come to this more later. Okay, this is going to be the one of the toughest part of the X.AL5 explanation. So you are aware now there are 3 security layers, and you are now aware of 3 security planes, the activities. Now, if you create a matrix like this, there are actually 9 modules, okay, that is being developed in this table. Now, these 9 modules really means that each module tells you, if you want to secure your management of your infrastructure, there are 8 security dimensions, 8 different kind of controls to consider in this module 1, okay. And each of these modules, all the 8 controls are all totally different between one another. Okay, that is what it really means. So what it really means at the end of the day is because there are 8 of them, and there are 9 modules here. So altogether, there are 72 security perspectives that you have to consider for the entire network. Okay, that's what really it means. Now, if I were to come back to this diagram again, just now earlier on when you see the diagram, right, it was very colorful. But now I make it dark and I want to focus on the color codes. Can you look at the color code here? Management plane, control plane, and user plane. Okay, now through this example, I will look at the network like this. Okay, anything that is in red, okay, is within my charge. Okay, it's within my charge. I am the, let's say for example, I am the CIO. Anything within this network diagram is my charge. And because this 1, 2, 3, 4, 5 are really more into the infrastructure and more into the management aspect, I know that I only need to apply the management controls on these relevant networks. Anything that's outside here, since it belongs to someone else, I do not focus on it. Okay, and I scope my work down to focus my network controls on just here and upwards. And because all these networks deals with applications and management of services and stuff like that, okay, I have the green and the blue, which is here. Okay, which means that for these subnets, okay, I have to put in a little bit more controls, okay, to focus a bit more to secure networks like this. Okay, so this is how really it's applied. So the point here is that when you first see the diagram, it looks so complex, like almost like you have to do everything for every single subnet. Not really. Okay, in this case, through this X.805 application, this is how you identify what is the important things to focus on. Okay, I will show you a table later. This diagram is just to give you an example. Actually, I'm not too keen on going through all this module 1, module 2 and stuff like that, but just to give you some examples, some of the examples about what each module does. Now, for example, the objectives of each module have certain kind of objective. Like for example, module 1, infrastructure management, is concerned with security, operations, administration of the individual network elements and stuff like that. Now, I give you an example what I mean by module 1. If you have a router, okay, a router is really a part of the infrastructure, and the only time you use it is because you are managing it. A router is not used by end user. Okay, so now you have to think, how do you secure a router considering the 8 security dimensions? So the module 1 has the following key controls and objectives to tell you how to secure this particular area. I will skip through some of these things because it's very dry, and I don't like to explain this when there's no example. So I give you another example. Module 9, applications and user. Now, an email program is an application. Okay, an application which is used by the end user. So considering, because it's an application, so you have to consider how to secure things like user data. Okay, maybe like things like how do you protect the passwords. Okay, your application must first protect the password, first maybe like mask out the password entry, stuff like that, and then do the encryption right at the application layer before it transmits out, kind of thing. So, so this module is, the controls are entirely different from how you secure a router. Okay, so to give the best example, I always like these next four examples. This example will show you how do you secure a network in different application contexts. Let's start off from internet service provider. Now, every internet service provider definitely have a router, distribution switch, maybe RAS. Okay. Now, these are part of the infrastructure and they are to be managed, so they are here. Okay. The protocols used for the infrastructure, okay, that powers the network, okay, makes it possible things like BGP or OSPF. Okay, and lastly, things like management software and email protection software are really part of the infrastructure that manages the entire network, and then is used by people like administrators to protect the network. Okay. Then we have the other end here, applications. Okay, things like email accounts and web pages are really at the management perspective. The protocols used by the applications are things like SMTP, POP3 or HTTP, and the end user are really the client software itself. In between, services. There are 3 different kinds of services. The management service will be things like Radius and SMP. These are really the things that manages the network from a protocol point of view. DHCP is a control service. Okay, without this, basically everything doesn't work here. Okay, so it's really in the center. And lastly, end user. Okay, end user may use things like DNS. Okay, finger, who is. Okay, make use of service, but really it's an end user perspective. Now, if you would ask me, Ting, what does this mean when by breaking down into this table? It really means that I am going to put in the relevant resources in protecting this. The controls that I put in this really is different from the controls I put in here. Okay, to give an example, let's say BGP OSPF is dealing with routing information. Okay, so routing information are very sensitive. So I have to consider how to make sure that only authorized routing activities, routing configuration could take place in here. Whereas for these protocols, okay, I can't really secure it because it's used by end user applications, and it really depends on what application you use. So maybe what I could do is, in order to prevent people from exploiting the protocols, I limit the protocols to certain kind of access. For example, I do not allow people to use port 25 SMTP or port 110, port 3 service. Maybe I'll force them to use secure SMTP or secure POP3, okay, when they access their network kind of thing. Okay, so this is just an example. The controls that you focus on are different. Another example, this is a probable MNC environment. Now, MNC environment, okay, almost similar to the ISP, but the things that are different is things like this. Okay, they are using RIP. They don't use things like OSPF or BGP whatsoever. Okay, and they probably be using things like IPsec or VPN access and stuff like that. Okay, and then they probably use things like VoIP and database encryption and stuff like that. And you can see they are totally different. Okay, and because they are totally different, the way how I approach in recommending controls to secure each of these relevant modules are different. Okay, because first of all, I must ask myself, if I'm an ISP, today if I'm ISP, I'll tell you the right way to approach to secure your environment is to start from here. Because really, as an ISP, your business is in the infrastructure. Whereas for the MNC, okay, the infrastructure, okay, is important. But what really is more important is the applications and the services that you use in your environment. Okay, so you will start focusing on here first before moving down, kind of thing. Okay, another example, ASP. An ASP provides and manages applications for people. Okay, so they are really concerned with only managing this. How the users use it for all those purposes is not the ASP problem. Okay, now in contrast with ASP, I have what we call a small business company who does not own the infrastructure. They may probably outsource the network management to service providers. So their concern really is more on protecting things like this. Okay, protecting things like this from the perspective. Okay, these four examples I want to show to all of you is that because depending on the complexity of the network, depending on what business you're in, depending on what areas of network operations you're using, okay, you could focus your resources really rightly to focus protecting at the relevant portions instead of focusing everything. Imagine if a small business company has to worry about every single thing. It just doesn't make sense. The problem with checklist is that it forces even small networks to focus on everything, which is really totally not right. Okay, so let's talk about the relevance of the X.AO5 networks today. It's really comprehensive and end-to-end network security, and is applied to any kind of network technology. It can be applied to any scope of network function, which are all like this, and it can be mapped to existing standards, okay, which is useful for enterprise service provider and government needs. What do I mean by that? Let's talk about relevance of X.AO5 to 17799. Okay, for those people who have not heard of 17799, it's basically an ISMS code of practice standard. Okay, here are the 10 or rather 11 domains of the ISMS 17799. Okay, X.AO5 actually has now been an ISO standard. Okay, it's really 18028 Part 2. Okay, in this ISO, okay, I myself belongs to the Singapore chapter of this ISO IEC/JTC1/Standards Committee 27/WG1 previously, but now it's known as WG4, Working Group 4. Working Group 4 is now focused on network security standards from other standards. And it has been agreed at the Standards Committee 27 level, okay, that every standards that you see here, okay, now developed, are slowly being used to complement 17799 and 27001. Okay, anybody knows that 17799 in the year 2007 will be called 27002? Anybody knows that? You know, right? Okay. Now you heard it from me. Okay. In the year 2007, okay, I think it's December 2007, there will be no